Pre-Coaching Friday. It's that time again. And we are talking about Git Ops. Git Ops Day. I've been getting questions about so many things, as always, and the things that I have been getting a lot of questions about this week, well, one of the big ones is, what in the world is Git Ops? Because I talk about DevSecOps, but now, for those online, you've been Googling, been looking at things, been looking at the news, the feeds, the tech news, what's coming out, and you now see something called Git Ops as well. And hey, for everyone showing up, welcome, and thank you for showing up and hanging out with us today. So now we have DevOps, we have DevSecOps, and we have GitOps, which gets really confusing because I've talked about DevSecOps on this channel before with the stream, and DevSecOps is basically developing secure operations, more or less. It's a philosophy. It's not quite any specific way of doing something, but it's a philosophy of how to develop secure operations. But what in the world is GitOps? So this is a pretty juicy one because this upcoming next week on the 15th of October, so if anyone's watching this late, you might have already missed this, but for those who are not late for the 15th of October 2020, there is a presentation coming from Microsoft where they are doing basically a Raspberry Pi cluster with GitOps as the future of DevSecOps for the operations side. And if we're talking about development secure operations, there's an operations side of DevSecOps. And on the operations side of DevSecOps, since I'm a person who spends a lot of time talking about DevSecOps and working with DevSecOps, it's pretty much my life. Well, if we're talking about DevSecOps, then on the operations side, something that's wildly critical to what we're trying to accomplish in the operations side of DevSecOps is GitOps. So I'm going to actually start whiteboarding because this is something that gets so confusing that it's not going to become any less confusing without me charting some of this out so that even I don't get all too confused. So let me shrink my face here because no one wants to see that. It's throw me off in that corner. And while I could type some stuff, this actually is not what we want to look at. We want the whiteboard of, I guess, justice and everything else. So let's just dig right into it. What is GitOps? Because it sounds like something from the bottom of the ocean with 8 legs. And we're not talking about an octopus, but we're talking about GitOps here. And what GitOps is versus, we have versus DevSecOps. We're just going to make a thing over here. So we have DevSecOps and we have GitOps. If we want to know the difference here, DevSecOps, we can chalk that down to and there's an aspect of DevSecOps that's just secure development as well. And then there's secure operations. So we can branch that out. So we can say so let's break this out. And, when we're talking about DevSecOps, we're talking about secure development and secure operations, or maybe the development of secure operations. It gets a lot more granular from there. But, if we're taking a bird's eye view, we want to take a look at, at the highest level, what in the world is DevSecOps? Because that's something I talk about often, and we do DevSecOps workshops. But the secure development that's still DevSecOps, even if you're not dealing with operations. And so if you were to go get a job being a DevSecOps expert, you might only do secure development. Or alternatively, you might spend your days, day in and day out, doing secure operations. And then that brings us to something else, which what's associated with creating and developing secure operations brings us this thing called just a small offshoot that you could almost look at as a subcategory. And at the same time, this isn't necessarily a subcategory of DevSecOps, but in terms of how GitOps works, when we start to integrate security into GitOps, and when we're talking about basically working with operations and secure operations, then GitOps is a part of DevSecOps. Now, DevSecOps, once again, isn't necessarily part of GitOps, but GitOps is more or less a part of DevSecOps. And if you weren't confused, now you are. So let's now start talking about GitOps, because GitOps it's the operation side. So let's just write it down. And this I'm going to make a little specific here. So GitOps, this has to do with Git repository development for operations, and then the integration and implementation of that. So that's a very confusing thing. So if you've ever heard of GitHub or Git, like there's another Git repository type tool, there's all these different Gits. But regardless of which one you've heard of, we have the development of code repositories. And if you don't know what a code repository is, let's talk about what a repository is real quick. So I'm going to oversimplify what a repository is here. And by oversimplify, for those of you who are developers, you know what I mean. This is very oversimplified. A repository, we could think of it as saved code. Basically, if you have some form of code, whether it's data that's going to be used with code, or whether it's a bunch of saved scripts, or it's just if you have a folder and you put some stuff in it that you're going to make some code use or something along those lines, or a program use or an application use, we can think of that as a repository. That's sort of just a really straightforward way to think of, like, what's a repository? You could almost think of it in a video game. A save file in a video game is kind of like a data repository for the progress of your video game. So that's a way you could almost think of a repository. It's once again, I'm oversimplifying here for those who are a little more new to this stuff. But anyways, a repository it's just basically saved code. And GitOps has to do with which I'm going to just outright say this is the continuous integration aspect. So when we're talking about operations, we're talking about continuous operations. And then we have a so you could think of this as just like building or construction, but otherwise repository construction. So basically pools of data that are going to be used to continuously integrate into something that just runs forever. So if we're talking about like Facebook or YouTube, both Facebook and YouTube, which I am streaming to both Facebook and YouTube, and if you are joining us from the YouTube side, feel free to be an audience to us. If you want to ask questions, come join us on the Facebook side, is where the discussion lives, and then anyone can watch from the YouTube side. So if you prefer to be a spectator, then join us on YouTube. If you prefer to get more involved, then join us on Facebook. But when we're talking about Git repositories and like this idea of a repository and this thing called Git. This whole idea of Git, so we could think of you can just associate Git with repositories if that simplifies it a little more. Because now we're trying to wonder, like, what in the world is Git? Why are we talking about repositories? Why are we talking about all of this, and how does it have anything to do with this DevSecOps stuff? So, anyways, for those of you who've been following me for a while, this is just growing on top of things that I've talked about in the past. For those who have not been present for our DevSecOps talks, some of this might start to get a little confusing because this is now knowledge growing on top of past knowledge that we've talked about and discussed. But Git Ops is a big deal. And when we're talking about Git has to do with, like, it's some sort of tool that saves code. That's what Git is. So when we hear Git, that's a tool that saves code. We could kind of think of it that way. Once again, oversimplifying here. And then when we're talking about continuous integration, then if we have YouTube and we have Facebook, Facebook can't go down. YouTube can't go down. If you're trying to watch YouTube and all of a sudden YouTube goes down for the entire world for 24 hours, people would just start to freak out. Same thing for Facebook. People would just start panicking. Like, there would be riots literally around the world, globally. It would be mass chaos. And so really, those platforms, YouTube needs to remain continuously available, and Facebook needs to remain continuously available, and anything else on the internet, your websites and whatnot. And so you have to have a way to update them, though. You have to have a way to update your continuous technologies. So Google, they have to update the Google search bars and the things like that. And if you've used different websites, there's LinkedIn, there's Facebook, there's YouTube. Recently, YouTube's been making some updates, and they added like a night mode and a day mode. And then we could switch all the way over to Facebook, and they've just completely changed their entire interface. But how is it that both YouTube and Facebook can change their interfaces just like overnight? You wake up in the morning, you go to the website you go to all the time, and all of a sudden things have changed, and you're like, what is going on? And you might be angry, you might be excited, you might wonder, like, why did they have to change all of the things that you just got used to? Or you might even be thinking, I really like this a lot better. So some of you who are on both the YouTube or the Facebook side, or both, you've probably seen these changes. Well, how did they make these changes possible? They made these changes possible with Git Ops. They made these changes possible with Git Ops because Git Ops says we can have something that's running, a computer that's running and doing all of the things that it needs to be doing, but we can update the firmware on the servers hosting Facebook or YouTube. We can shut different systems down and manage things. We can do patches somehow. We can do all these things, and then we can also add updates. We can change the interface entirely without anything ever going down. Enter Git Ops. So, and someone made a good observation. LinkedIn changed quite a bit to try to look a lot more like Facebook, and LinkedIn recently started integrating what's called LinkedIn Stories. And so LinkedIn now is going to be having LinkedIn Stories. If anyone has never heard of Facebook Stories, Facebook has this thing called Facebook Stories where you have these little things that pop up at the top of Facebook. I actually barely even know how to use Facebook. I see them, and I think I've tried it once or twice, so I don't even know how Facebook Stories works. But LinkedIn is now doing the same thing, and they're calling it LinkedIn Stories unless they decided to change the name. Real creative here. But creativity aside, LinkedIn won't go down when they make all of these updates, and neither did Facebook when they added all of these features and different things. So this has to do with continuous integration. Integration that doesn't cease, it doesn't stop. And then, of course, when we're talking about repositories and repository construction, well, if you're going to make an update, an update has to be saved and stored somewhere, because an update is basically a file. So if we have to change the way that LinkedIn looks or works, or change the way that Facebook works or looks, then someone has to do some work and do all of this testing and have like a mock or fake environment of whatever this is, right? Just not even a real environment. It's a fake environment of Facebook, and then they make what Facebook is going to look like, or what LinkedIn is going to look like, and exactly how it's going to work, and then they save that code in a repository. And you could think of that otherwise as a Git repository, is what that would be called. And so there's a good question. What was in place before GitOps? That's a very good question, because I actually worked with that stuff back in the day. And that's actually a pretty good place to make a little tangent here too. So what in the world did we do before GitOps? I will tell you. So back before GitOps, we mostly used databases and dedicated code storage servers. So let me give you a network environment of the past, and then let me give you a continuous network environment of today, so that we can take a look at how has GitOps changed the face of technology, really, because it has completely changed the face of technology. I used to develop cloud from ground up. So if we say 2012, I mean, cloud and all that was big before 2012, but really in 2012, that's where we saw a significant amount of traction in the technology space. So we'll say technology in 2012, right? So if we go all the way back to, what we did before GitOps, what we would do is we would have, of course, we have our primary network. So we have, we'll do like a small business or something, just something basic. So we have a server. Well, we'd actually have different servers. So we'd have an app server. I'm just going to make all the servers yellow. Then we'd have a, what's that thing called in Microsoft? Oh, Active Directory. So we have an Active Directory server. Generally have that much, and then we have oftentimes a separate email server back in the day. And we'd always keep them separate, by the way. All of the servers would just be separate. And then eventually we started doing some basic clusters, but really, we would have this app server, Active Directory server, and basically an email server. And then we would create a separate update server. And we might have different update servers too. So we would have to have an update server for all the different versions of operating systems and all that good stuff. So we just have all these servers in the past. And then when we had workstations, I'll just say that people worked on and not just the servers. These are just user computers, basically. Let's duplicate a few, and we'll say we have a couple workstations who are working on all this stuff. So we have a bunch of workstations, and these workstations are all essentially going to be routed through a switch. So we're just going to say networking. And there's going to be more in there than just a switch, but we're just going to do this. So this was right before we started building early cloud. Or, well, this was in the days of when cloud was fairly buildable for just about anyone. So we would have all these workstations connect, and then basically the routing architecture, however that networking was built, everything would just go to all these separate servers. And, the reason why we'd have a separate server for everything is every single appliance was basically a repository. So that's the thing that gets a little confusing here. And actually, this is probably more like, this is probably more like 2010. Now that I'm looking at this is pretty old. So at this junction, at this point in time, before we had things like Git Ops, then a repository would generally be an entire server. And we might have all of the servers connected to a SAN, right? So we'd set up a big SAN, and then we'd set up different partitions, and so maybe all of the servers would just be connected to a SAN. Which a SAN, for those who don't know what a SAN is a giant hard drive with a bunch of like RAID arrays, which is basically having, you could have like 50 like giant hard drives. They weren't even like the small solid state ones. You'd have 50 hard drives that would all work together as one big, more redundant hard drive. And then that hard drive would be partitioned out, and the partitions would go to these different servers. So all these servers would just connect to one kind of mega hard drive. And this was kind of what companies would do before clustering and all that good stuff. So it was kind of complicated. So let's see. What is my? Let's go over to look at the modern. Let's look at modern network with 2020 with GitOps. Let's look at 10 years later, because this is probably pretty interesting. 2020. Yeah, we already know we're talking about 2020 technology, so let's just take a look at 2020. 2020 is a very interesting thing. So we can instead say cluster instead of a bunch of separate servers. And a cluster could be, who knows how many computers we want. Could be 100, could be 200, could be 500, could be 5,000, right? But we have a cluster, and then we have something like Kubernetes. And Kubernetes would sit on top of the cluster. And then we would have something called, oh, oops, let's see, cancel, make a new one. So then we have something called Helm. Let's sit up here with Kubernetes, which kind of lives in Kubernetes. But anyway, so now we have a cluster with this thing called Kubernetes that's running. And then instead we have this other tool called Helm. And it doesn't matter if it's one server. It doesn't matter if it's 5,000 servers. And let's say that we only have one server. We can still put Helm and Kubernetes on top of the one server, and let's say that down the road we know that we'll need 2 later, and then 5 later, and then scale it up in, as a business grows. A business can now buy one server that's at least enough of what they need for now, because now it's so easy to just buy a new server when you need one, and buy a new server when you need one, which is why if you have applications that can run on a Raspberry Pi is a really easy way to learn the same thing you can learn on enterprise servers, because let's say that you need more resources. Add another Pi. Let's say that you need more resources than that. Add another Pi. Add another 12 Pis. And for that very reason, Microsoft even uses Raspberry Pis, just like we do, for their Git Ops. There's a reason why I use Raspberry Pis for Git Ops. Honestly, it just makes things very easy. But anyways, we have Kubernetes, and we have Helm. So if we go back a little bit, all different servers. We have all these different servers. Well, instead of having all of those servers separate, we can just put it all in Kubernetes. So we can say that Kubernetes has Okay, so if we then have Kubernetes, we can just say all apps separated in containers. Generally, a server, you'd have repositories. You'd have a server that acts as a database, a server that acts as, all these random things. And yes, we finally are we're selling our own Pi clusters. Actually, is a thing that we're doing. We have a limited run right now, but we have some already getting put together and sent out. This is the Founders Edition one that we're basically selling a new type of supercomputer that works with this stuff. So that's something that we've been working on, but there's reasons for that. Let's see, let me make it a little bigger so anyone who's curious to see what it looks like, our little Olympiad Founders Edition powered by Pi. There's a reason why we do this with 2 Raspberry Pis. You can scale these out and get as many as you need to kind of basically build cybersecurity programs. Because it's the same thing that everyone else does, but we've been doing this for years. So anyways, with all apps separated in containers, you don't have to have separate hardware. You don't have, yeah, it's, oh my gosh, like honestly, life has become easier as a result of modern technology. It's 2020. I didn't invent the modern technology. I just discovered that it's there and started using it because 2020 has transformed. Like right here, we're already at this where we have all those servers. All of this can be on one system. Every single thing that's in yellow can be in one system, and then we can just scale out hardware as needed. So it's like, oh, maybe you start with one, right? And then maybe you're like, well, I need a little more power now because I'm running into a lack of resources. Bam, add another one. And then it's like you can just keep scaling them up. You can get more Pis, more systems, more servers, but you don't have to have like a separate one for everything. So the second you add a new piece of hardware, basically this tool called Kubernetes, and the way that it works, it distributes what's going on to all of the hardware appropriately so that you don't have to worry about, oh, let's see, what's the app server doing right now? Well, all of the apps are separated basically in software. And so then finally, here's what we do. So like what happens if all of this is continuous? So let me just draw a line here, and we're going to say everything in this container is, or in this little square is so you could think of this as like YouTube, right? Or Facebook, the hardware that everything sits on. So we have production continuous technologies, the technologies that can't go down. So if we want to then update the software on all of this, there's a way to do that. And what we want to do is we want to say, okay, so we have this continuous technology that can't go down. It can't go down. So let's just emphasize that. Just straight up, this can't go down. It'd be not for the well-being of the business. This just can't go down. But what if we do want to make updates? What if we do want to make changes? In the past, when we wanted to make changes, we would have to do what's called a server migration. That's what we would have to do. And a server migration meant, oh my gosh, it was the most painful thing. So I hate doing server migrations and environment migrations. They're just awful. So we might say, we might have a new email server, right? Well, if we want to basically get this email server going, this new email server, we're basically going to have to do this migration process where we're going to have to do some planning, decide on like when the potential outages might be. And what we might even do is we might, copy everything over from this mail server here and then turn this one on and then, try to go as fast and swiftly as we can. And then we basically like try to just quickly swap the new server and Voila. Okay, now we have the old server ready to decommission. And we're like, whew, all right, here we go. All right, now we're good. You know, we did it late at night, and I used to do on-call work, and yes, I would sometimes we would be on the floor at the data center. You could ask my old boss; he remembers what it's like sitting on those hard metal floors, and just like you've been working all night. It's 3 a.m. in the morning, 4 a.m. in the morning, 5 a.m. in the morning, and you're just like, oh my gosh! And then the data transfer is taking longer than you expected, and now it's 6 a.m. in the morning, and people are about to come into work, and you're like, oh no, people are about to come in. The migration's not even done. The CEO is going to be angry and livid, and you start sweating bullets, and then finally it's like, okay, it's like 7:30 and it finally finishes the migration, and you're like, oh, okay, everyone, let's go home and sleep. But you can't, everyone can't sleep yet now that you've got everything up and running, because now what if something went wrong in the migration? So someone on the senior staff still has to be present and can't just go to bed yet. And so I remember, like, we'd pull those all-nighters, and you'd be like, I remember my boss one time, he's the director, bless his soul, he's like, he was like, you need to just go home. And I was like, but we're not done yet. It was like 3 a.m. in the morning. He's like, no, he's like, one of us needs to have slept in the morning. And I was like, all right, that's fair. And he's like, if both of us can't function tomorrow, like, we're in a bad situation. And so I just remember being like, oh, okay. And I was like so worried. I was like, I need to go get some sleep. And then I ended up not even being able to sleep because I'm like all anxious about what's going to happen the next day. I think I got like 2 hours of sleep, get up, and then all hell's breaking loose because now that the new email server is up, but now there's a bug to iron out, and there's something went wrong, and you know, most of the users can access their email, but then there's the like 30% who can't, and then now you have to figure that out too, and it's like hundreds of people. It's crazy. Like, that was what it used to be like. That's what it used to be like until today. Now you just slap Kubernetes on there, and Kubernetes, you know, let's say that you do need that redundancy where you want to upgrade the hardware. Oh, you want to upgrade the hardware, then just bam, you know, just add more hardware as much as you want, whenever you want. And you don't even have to take the old stuff down. Just keep it running. You know, turn on the lights and you're like, oh yeah, is Kubernetes up and running? Oh, it is. Oh, great. Oh, do we have failover set up on it? So if one server goes down, another one will come back up? Oh, really? Oh, wow, we have 50 of them. Oh, really? Okay, and so all of a sudden we're like, okay, well, let's add another 50 more. Oh my gosh, yeah. Caffeine is a must when you're doing it in the old days. Nowadays, you can just let Kubernetes do all the work. Like, honestly, it's one of the most, like, insane things for someone with my background to think about, because those all-nighters meant something, and now it's like none of that's necessary anymore. None of what I used to do is even remotely necessary. No one has to pull all-nighters on migrations because we now have enter GitOps. We now have a way to, let's say GitOps comes along and says, let's make a little opening for the operations. For the operations to get updates, for the operations to get all the things that we want them to do, so that we can make updates to something like Facebook, and we can make updates to something like YouTube or LinkedIn. So now we're like, okay, so let's take a look at this new thing, and let's say we want, now we're going to do something very similar. We're going to get another cluster over here. And this one, we can do something simple that's easier for development. And we can just say, let's get Docker right here. And then we could get something else like a few other tools like Jenkins and Terraform. As a matter of fact, you don't even need Jenkins. I would say let's just say Terraform for now. Learn how to use Terraform. That's a pretty sweet tool. So now we can say instead of using Kubernetes, we can just have Docker, set up like a little Docker swarm because it's a little more straightforward for just developing things. And then Helm works with Docker containers. And Helm allows you to pull Docker containers out of a specialized repository. And so then our Git is Docker Cloud, basically, so Docker Hub, and GitHub together. So then we have a different kind of Git option, which is going to be GitHub plus Docker Hub. Which maybe I should make Docker green so that it goes to show the parallel between Docker and Kubernetes. So let me flip-flop my colors here. Because really, Terraform is kind of part of making development easier and making testing easier and making a lot of things easier. And then our alternative to Helm here, the thing that allows us to even get it into Helm in the first place, which is this tool we're going to use at Kubernetes. We get a GitHub plus Docker Hub here. And then here we go. Duplicate this. And then what we do is we now have let's say, test environment. Which, if you've seen me talk about DevSecOps, this is pretty familiar looking stuff. So then finally we have our little test environment, which let me draw a little outline around it to complete the image here. And voila, basically we now have GitOps, which GitOps right here is where we're using Git, essentially repositories. We're using repositories to streamline our ability to just add updates. And so we can literally just use Helm here and make all of our development in Docker, set up Docker on Raspberry Pi or whatever, or Raspberry Pi cluster, and add as many Raspberry Pis as you want. As to where over here, maybe we're not using Raspberry Pis in the production. Maybe the production, maybe this is like multi-million dollars worth of servers or multi-billion dollars worth of servers. Doesn't matter. It's all the same so far as technology sees it. And then, we build in Docker. We can use tools like Terraform to make the building a lot more straightforward and the testing a lot more straightforward. And then we can use this GitHub plus Docker Hub tool, feel free to Google those, to basically create things that we can pool with this tool called Helm for just continuous integration and continuous updates. So there you have it. So it's like you just take your small thing and your small environment and do all of your development, do all of your testing, and that's where the DevSecOps part comes into play. But the GitOps part is, hey, I got my development, I got my tools, now I need something that makes GitOps easy. And there's also, let's see, we have GitHub, and then we have, what's that one that looks like Firefox, but it's like a Git? Let's see. So we have GitHub. I use GitHub quite a bit. I haven't been using it as much lately, but historically I used a lot of GitHub. So GitHub is a tool built for developers. So if you've never heard of GitHub, this is a great place to start if you're trying to get into just Git in general. There is, what is it called? It's like Git something. Git. feel like let's see. There's so many tools out there. But I want to give you the names of some of the ones that are a little more popular. There we go. It's called GitLab. That's the other one I was thinking of. GitLab. I think it's .com. Yeah. There we go. GitLab. Like, these are just two different options. And meanwhile, you can even see on Git, we have Docker Hub. Let's see, if I sign into Docker Hub, well, I won't sign into Docker Hub right now. But just know that there's GitHub and there's Docker Hub. That's all you need to know. And there are options for stuff. And there you have it. So these are just things that you want to have in mind for if you're trying to get into GitHub. And I guess there's a couple others. There's Git. I haven't heard of Git Dorker. Let's see what that is. Oh, that's GitHub. Oh, that's a project. Oh, here we go. Yeah, so we have Dorker over here. Anyways, there are a lot of options out there. A ton of options out there for Git. And really, like, if you're trying to do development, there's no reason for you to not be able to find some free resources that you can learn at home with. There are just so many options. And honestly, so many of the options are just really good. And we've just talked about some great tools just now. So absolutely feel free to just go and dive into some of these and just kind of take some time to see what they are in the first place. Take some time to figure out, like, what's Kubernetes, what's Docker, and then how does something like Docker and or Kubernetes work with something like GitLab. So one of the big ones is someone made a good point: misconfigurations and secrets in GitHub repos. Misconfigurations are one of the most frustrating things ever. So having a good repo tool, like a good Git solution, it can really help manage like misconfigurations and just configuration management and policy management, just managing everything that you're trying to do. When you're working with technology, any of you developers out there know that there is an amount of tedium involved and a lot of lining up everything and a lot of planning and making sure that you have, the right configuration for this set and the right configuration for that set, and then you got to manage your port configurations and your security settings. And then something else that I do like to just always add on top of things, because I'm a DevSecOps person and we focus on the security side, especially with everything that we do, is GitOps. You can have basically you can just slap SIM and monitoring right in the middle of this. And if anyone is new to the idea of what a SIM is, feel free to ask. For those who've been watching for a while, you probably already know what those bits are. But this is the security side of GitOps, where this brings us into the DevSecOps, where now we can have SIM and monitoring, and basically also have our security, where we can also have things like firewalls built via code. So you can have like a firewall and a container, and then you can have that as part of your continuous integration process, where you have, proper port security and proper monitoring and tools to also help you identify misconfigurations. So using a tool like a SIM can help you identify not just vulnerabilities, but also tools like identify things like misconfigurations as well. So sometimes, when you're using a tool like a SIM, the Security Information Event Management, there's a benefit to operational management and operational monitoring as well. And so when we're talking about like system monitoring isn't just for security purposes. System monitoring is also just to make sure that configurations seem to be working properly. The configuration monitoring allows us to also like make sure that the system's not going to go down later, or that we're going to run into other issues, just all kinds of different types of things. So anyways, I wanted to focus on GitOps today, and that was the big focus. Some questions that people have asked that actually I did some whiteboarding earlier in the week that I'll kind of close on. And I got a lot of questions, but this is a pretty good question. Is someone was wondering, I mean, a number of people actually were wondering, how in the world does networking with something like Docker work? So I made a little diagram of a Raspberry Pi with Docker installed. And let me get a little pointer here. So if we're taking a look at a Raspberry Pi, so let's just say this whole square right here is a Raspberry Pi. And we're wondering how Docker works when you're trying to build something with Docker, whether it's on a Raspberry Pi or a server. It doesn't really matter which one. But when you install a tool like Docker, and Kubernetes and Docker are a lot alike, you can actually use Kubernetes and Docker together, which is why, you know, even on the diagram here, I do development for Kubernetes using Docker. So if I'm going to be using Kubernetes, it's just easier to do my development in Docker for me personally. I'm sure if you spend a lot more time with Kubernetes, I spend less time with it because it runs on production things. And so if things are running, I update it when necessary. But the thing that I spend all my time with is Docker, because that's where I do all my development. But I definitely do all my production with Kubernetes. So it's not that I don't get experience with it, but considering Docker, we want to know, like, how in the world does Docker work if you're trying to do some development on there and you're trying to build a little lab that you can do all of this stuff on. So basically the way that works is on your Raspberry Pi, if you install Docker basically has a networking engine. And so anything that you then install inside of Docker can then like network with the outside world. One thing that if you were to ever run through, like from my website, this Olympiad white paper right here, it actually walks through like how do you build Docker in a Raspberry Pi. And then if you follow this white paper exactly, you'll notice that basically the Pi hole that lives in a container here, this walks you through how to build a what's called a Pi hole in a Docker container. Some of you have done this who've been watching, so you already know what I'm talking about. But this shows code for, you know, how to pull things from repositories. So this right here has GitOps associated with how I built this white paper. I'll let you dig through that, but what that white paper is showing is how to install Docker on a Raspberry Pi. So if this diamond right here is Docker, let's say that's Docker. We just installed Docker. Then basically, let's say that this circle is a container, right? Any old container. It could be a Pi hole that you installed in Docker. Then depending on how you configure that container, you can basically punch holes in the networking so that the Raspberry Pi's physical ports map to the container. So it's a really confusing concept. But just know that if you're using something like a Raspberry Pi with Docker, or just a server with Docker, whatever you're doing, everything has to do with just like the networking and then understanding how the networking works. And then that's where the integration happens, which it has to do with just understanding the networking engine. So I guess that's where I'm going to give everyone a recommendation for something to research based on GitOps. Is the reason why I'm showing this is I would like all of you to spend some time, for those who aren't very familiar with how containerization networking works, and maybe take some time to wrap your head around how does networking in Docker work. How can you basically set up Docker on a server and then update your little Docker containers? So like if you have a Pi-hole container that you install on a Raspberry Pi and you're using that, how can you then create things to go and then learn how to manage and update your little containerized services or tools that you install. And so that might be a little bit of a confusing thing to recommend everyone do. So feel free to message me about that and talk to me directly if anyone wants to really spend some time on that, because that basically just learning the networking engine is the thing that I highly recommend everyone spend some time doing. Because if you want to get into Git Ops, the first thing you're going to want to understand is how are things going to communicate, how do things communicate, and this is a great place to start. So I'm going to just make that recommendation. And then on the 15th of October, Microsoft is doing something, let's see. Microsoft is doing an event on the 15th of October. Maybe what I'll do is I'll put that event in the description or in the chat after this, so that, you know, if you're watching this now, just give me some time and then you'll see in the comments or in the description on YouTube. I'll put the link to an event where Microsoft is going to be showing how they do Git Ops with a Raspberry Pi. Not just a Raspberry Pi, but just about anything else. And they also use Kubernetes, and there's a reason for that. So I want to basically just get everyone that link. That's what I want to do, so that you can see that, so that you can watch. His name is Lior. The presenter's name is Lior, and I will get that link in so that those of you who are here before the 15th of October 2020 can take a look at how GitOps works from a Raspberry Pi up into something like Azure cloud, because that's more or less exactly what this is right here. So Microsoft is going to basically just show how they do it on the 15th and how they're going to be doing it, going from Raspberry Pi all the way to doing GitOps with a into Azure basically. So anyways, thanks everyone for joining. And oh yes, so like learning how to update Portainer. So someone made a good comment before I go. So like for those of you who've set up Docker with Portainer, which is a container in Docker, Portainer is something that you'll see needs updates every now and then. And learning how to do continuous updates on a tool like Portainer, that's a GitOps practice. So learning how to do that update and then keep it continuous, that's also a great exercise to go with all this. So anyways, yeah. So if anyone has any questions about that stuff, feel free to ask. It's awesome, and I'll get that link. See you on the 15th of October. See some GitOps from Microsoft.